Okay, hello, welcome to my Cycle 5 presentation. This chapter, I'll be covering chapter 16, 17, and 18 and 19. Alright, so let's start with chapter 16. Introduction to Controller-Based Networking. The data plan. So the term data plan, it means that it is the task of networking device forwarding message. So in this picture, well, I know this is very simple. PC1 is sending a packet through this way, the packet to the switch, and it passes through the router 1 and 2 and 3. And they do forwarding here in this way and receiving each other. So it gets information from routing protocols. The control plan. Alright, so before the data plan sends anything, it should have an idea of, is it going to work properly? When the router data plane tried to match the routing table, and if there's not matching route, the router discards the packet. So in this picture, we can see 3 different routers and plane systems. This is traditional network feature, and each router sends the packet through the data plan. And OSPF, which is open shortest path first. It runs on each other too. Next, the management plane. As the word management says, it is all functions that we use to control. So, Telnet and Secure Shell, which is SSH, those are 2 of the most management plane protocols. We see Telnet and SSH as an NPC log here, and this is management plane with protocols. Controllers and centralized control. Let's talk about the distributed control plane. Allocating control protocol functions across multiple processor levels in the network system. Each router we're using its own OSPF, and to make them to work, well, distributed control plane processes use messages to communicate with each other. Alright, so let's do the SBI and NBI. SBI, it refers to the southbound interface, and NBI is, yes, northbound interface. Easy. Start with SBI. Okay, here, look at the picture on the right side. We have interface and controller, which is next to each other. However, it is located on the south way. All devices are located below the controller. So, it's in the south way, so southbound interface, SBI. Next, NBI, northbound interface. This figure shows that the controller can add entries to the device's tables. So how it works are very simple. The controller, it gathers information about the network, and it creates a centralized repository of all information of network. It enables network programmability by opening controller so that it can be used by other programs. Well, I don't really want to spend on the first chapter as usual or the previous video, so I will talk about ACI and move on to the next chapter. ACI, Cisco Application Centric Infrastructure. It is a holistic architecture with centralized automation and policy-driven application profiles. And it delivers software flexibility with the scalability of hardware performances. According to the article I found on Google, well, because it was a bit hard to understand perfectly from the book what is ACI and the concept of it for me. However, this chapter is all about reading stuff with the concept of ACI after I describe this one. So, let's go to the next chapter. Chapter 17. SDI, okay, what is that? Cisco Software Defined Access. Okay, so what is SDA? Cisco Software Defined Access, as I said. It creates a brand new way to build campus LAN with traditional method of networking. This one still uses a physical network with switches and other services. And this picture, these users are DNA center is the controller, which we see for SDA networks in the middle. Alright, so let me talk about a few things that we should know before we get to this chapter. First, overlay. The mechanisms to create VXLAN tunnels between SDA switches, so it is using for transporting traffic from fabric to fabric. Second, underlay. The network of devices and connections to provide IP connectivity to all nodes in fabric. And fabric, the combination of overlay and underlay, which together provide all features to deliver data across the network. Next. Alright, this is a concept of overlay and underlay. The overlay is at the top of the figure, and there are only two switches, which is fabric edge nodes and VXLAN tunnels. So the interesting part is that building SDA, we have to make a decision between two choices, creating an underlay network or adding new configuration. So now we will see the nodes which supports hardware and software depending on the rules. Fabric edge node, a switch that connects to endpoint devices, and fabric border node, the switch that connects to devices outside SDA's control, and fabric control node, a switch that performs special control plane functions for the underlay, requiring more CPU and memory, of course. So this is a traditional access layer design, and we have distribution layer 3 switches, which is acting like default gateway, and HSRP for better performance, and layer 2 switches, ether channels. It allows balancing too, and for the layer 2 redundancy, STP or RSTP manages in campus or preventing loops, or blocking ports like on the right side, this one. And SDA overlay, software defined access. The overlay network VXLAN explains IP mobility, which enables users to access the same network over any network. You can get a network environment, service, and security policies that were applied based on IP addresses are managed collectively from the central controller. Network automation reduces operational burden by automatically installing equipment and simple IP management. Chapter 18. Understanding REST and JSON. REST is a type of API representational state transfer. Its popularity as a type of API in networking automation applications. So I'm going to list few points. First is client-server architecture. So there are many applications using client-server architectural model. Well, okay, so this is a feature of client and server operation with REST. And we see client and server, and they're sending and receiving the data, and URI and use of HTTP for sure. So while many REST APIs use HTTP, the use of HTTP is not a requirement for an API to be considered RESTful. I don't know if it's right or wrong. Okay. Stateless operation. So stateless attribute of REST APIs means REST doesn't record and use information about the one API exchange for the purpose of how API exchanges are processed. Alright, so cacheable. Well, for example, when we're getting inside of the browser and it is surely loading a web page, and it has contents, of course, and advertisement or banner is changing sometimes, or some objects are changing. So we better download the object what we want to get so that we won't download it again. That's what is cacheable for. Alright, so chapter 18, this is very simple and short, but I should talk about this one. Accurate, complete JSON data with one object, 2 keys and 2 JSON list values. Well, by the way, JSON, we can think it as lightweight data exchange format, syntax format of JavaScript, independent of programming language or platform. Okay, so let's get back to the topic. So this one, it has matched with pair of brackets to begin and end the point, and it has colons to start and finish the word, and it's just having 2 key values pairs inside the object. It just looks like a coding system. Next, chapter 19. Understanding Ansible, Puppet, and Chef. So this chapter is very familiar for me. So we use configuration mode in Cisco. We do use copy running config startup config to configure to startup config file, and the router will be booted, and the device will load the startup config into RAM as running config. So the configuration drift, well, the book explained well in other example, but what is understood is application or owners, they need to make modifications to their application and the underlying infrastructure to continuously improve the product, what they provide. And those modifications happen, the configuration of the app and infrastructure changes. This is configuration drift. So this is configuration drift in branch routers. This is just a simple idea. We see 2 branch routers and they are having different configuration than other branches. So okay, so we put the Alice, Bob, Hi, and Chris there to the folder, and this configuration file is existing on each device. And now it seems like they're existing on centralized server too, because they're in the middle. And okay, so this picture, I have never seen this culpable example, but this is comparing the differences between versions of the file, which is very important in this chapter. So minus signs line, it shows that it has been changed, while to lower highlighted lines shows the new version of each line. So it seems like control software solves many of the problems with tracking the devices and comparing. They do compare, they do give us the result like this. And this one, okay, so automated configuration management software asks for a copy of the running config file in step 1 and 2. In 3 in here, the configuration management compares as we talk about the ideal config file with just arrived running config file to check if there is any differences. Okay, the last one will be Ansible push mode. So Ansible can do config provisioning and config monitoring. But if I can choose, I would say it fits more in config provisioning, and for the config monitoring, Ansible uses logic modules which detect and list config differences. Alright, so this is my citation, and thank you for watching, guys.